What is light? Is it an element? Is it a particle? Is it a wave like the ocean? Or is it just the light that came from above? In the late 1600s, Newton proposed that light is a stream of particles or corpuscles, but his theory was opposed by a Dutch physicist named Huygens and proposed that light is a wave. This issue has raged on until it was settled by an experiment that we will do today, Thomas Young's double slit experiment. Now the question is, does light behave as a wave? In this experiment, we will use a laser light and the two wires in front of it. The two wires will act as our two slits. This is the normal light we can see without the slits, just a red dot. And this is the light with the double slits in front of it. We can see that there's a vertical lines and blank spaces between. Here, you can see the actual picture of the light. Why is there many vertical lines when we just use only two slits? If light is a particle, we would just see only two parallel fringes where the two slits at. However, we said earlier that light behaves like a wave. That's why we can see not only two, but many parallel fringes. This phenomenon happens because as the light passes through the two slits, the wave of the light interact with each other that makes this kind of pattern above. When they meet peaks and troughs, the amplitude of the wave is increased, and that's what we call constructive interference, or the red wave you can see from above. But if the peak interacts with the trough from another, then we will have destructive interference, and there will be no wave there, or the blank spaces between the waves. This is what we saw through the light earlier where there are vertical lights, and that's what we call constructive interference. And the spaces between the vertical lights is called destructive interference, where the light cancels itself out. By this experiment, Thomas Young answers the question of the scientists and proved that light behaves like a wave.